pretty sturdy. So yeah, what did you see from rubbing the twill then? Anything at all? Not much came off on the sandpaper. Okay, so we see not much came on the sandpaper, so we can say it's more durable. The twill was more durable. Okay, so returning now to our list of materials we want to use for these two technologies. What would be your decision as a materials engineer? What material would you use to make a towel? So terry. Okay, so the terry was more absorbent, soaked up more water, which is what we said we wanted. Okay, and we had that it was soft already, so there's that. And then what material will be used for pants? Okay, so twill, we want a durable set of pants, and that twill was very durable. So this is an example of what materials engineers do. We've just looked at the example of fabrics made from cotton, but what are some other materials engineers might deal with? Yeah, plastic is a big one. You can do lots of different things with plastic, stone. You can make fleece with plastic, right? Not something we often think about, how to use making fleece from plastic, right? But there's lots of different ways we can process that plastic to do many different things for us. We can change its properties. And so if we return to our materials triangles, right? And we're thinking about how might the structure affect the properties of material, right? The rows, and then we connect that to our guiding question. How are the structure and properties of a material related to how the material was processed or made? All right. And now we can string it together. Now we've strung it together, the structure and the properties. So remind me again. So how would you say that the structure can affect the properties? How are the two related? Yeah. So let's talk about the terry. They have those large loops. And what does that do for you if you have large loops? How can that affect its properties? You're increasing the surface area when you have that large loop, and so there's more places for that water to attach. Yeah, so there's also the fact that you have these loops that have holes in them, and so the water can be soaked in that way. That's more places for the water to go. Okay, so that's to just give you an idea of materials engineering as a whole, and I know that you are all very hungry. We've gone a little bit over, but what we'll do is we will break for lunch. We'll handle the cleanup of materials, and then when we come back, we'll continue with this just with the from the perspective of a teacher. We're having our teacher hat on. Okay, so because I know that we had some questions about implementing these lessons. But for now, we'll just break for lunch. So it's on the schedule. It says 11:45. We can come back. We can have a full half hour. So maybe at 12:20, we will reconvene. 12:25. 12:25 is when we'll reconvene. So feel free to grab a bag of lunch, and again, you can go wherever you'd like in the Science Center.
One thing also, you notice the doors are locked. You have to keep them locked by policy.
Yes. So
there's a badge over there hanging, so if you use the restroom, you just take the badge and
right.
Hold it up to the brown box, out there. There's the red box. And
yeah, this will allow you to get back in. So it's going to be hanging on this door handle.
There's 2 vegetarian and 1 gluten-free. They're over here.
So we talked about this property of oxide. But the story is all about rock. So let's get to know about the properties and structure of rock. Let's talk about categories. Where are the three rocks? Remember this one? All right. So we got igneous, we have metamorphic, sedimentary. And is there anything you know about the structure and properties of this rock? Okay, so sedimentary rocks are soft and crumbly and good size. Any other comments you know about the other rocks? Melted rock, right? But the properties of that melted rock after it's burned, right, can be very different. Components can be very, very rocky, so that's just moving very fast. What about if it's exploded? Exactly. Yeah, so you can have really large pieces really ready to explode. So that's a different process. It's how, and that's because it's uncomfortable, so it's really rough. But the process, what other processes can change rock? So pressure on the rock. Are these processes natural or man-made? These are natural processes. Well, process properties of the rock. So at this point, so what we can do now is perhaps back on think about this vessel. Sure, I know as a question or two about how this is implemented, so just this down. So what are your thoughts on implementing this vessel in the practice? And give me the time to get to a lot of these characters what we have to talk about in practice. Oh, that's okay. Is it all right? Go for it. No problem. Cell phones, okay. So what do these kind of have in common? Your original list. It's really heavy on electricity. Does technology have to be based on electricity? No. Okay, so that's kind of what a lot of us think of first is things that are just modern technology. But technology is anything that solves that problem for us. And it doesn't have to be what we think of as modern. So we've got this list of technology here. Do you want to add anything now that we have kind of a more robust definition of technology? Anything that you could add to this list? It's pretty much endless now. Let's just throw out a couple just to kind of for some variety, since it's so heavy on modern technology. Let's just throw out another few examples.
Fork.
The fork, yeah. Paper clips. Okay, purse. All right. Anything else? Pens, okay. What about other processes? Let's get some, we said that it can be an object, system, or process. So what other processes could fit on this list? Okay. Any kind of recipe. All right. How to drive a car? Yeah, sure. So kind of how to drive a car, procedure for driving a car, sure. We can consider that technology. All right, so milking a cow. Oh, did you say building? I don't know why my mind just went straight to milk. I'm just going to leave milking a cow there, though, because I like that. But I'll put yours, too. Building something. All right, sure. Let's throw it all in. So we've got a pretty long list of technologies here. So it's a pretty broad term, right? A lot of things can fit with that definition, but really anything human-made. So what I'd like to do is kind of return to one of the technologies you had. I want to return to the spoon. And you mentioned when we were talking about the spoon that you could use it to dig a hole. All right. So would you keep it exactly the same way? If say someone says, "Okay, dig a hole for me," would you take that exact spoon and start digging? Depends on how big the hole is. Okay. So let's say I want to dig a hole for, let's say, for like the foundation of a building or something. Would you use that? Okay, so not too practical if we're just going to keep it that way. So what would you do to change that spoon so it would actually do what you want it to do? Okay. So yeah, we could kind of attach it to a machine, make it bigger, more durable. What materials would you use? Okay, steel. Good idea. All right, so who is the person who is actually changing the technology, improving it so that it does what's intended? That's an engineer. So that's how we can define engineering, is the process of designing or improving a technology in order to solve that problem or fulfill a desire. So that's going to lead us into now our next activity where we will be exploring some of the basic concepts behind engineering. So what we can do now is we can put our technologies back in their bags. And what we're going to do is we are going to work as engineering teams. Okay? Engineering teams, and we are going to solve a problem. So I'm going to tell you now the problem you all are going to solve. The problem is this. The Connecticut Science Center is about to open a new exhibit on bears. a new exhibit on bears. And they have commissioned a sculptor to make a bear to be displayed in the exhibit hall. Okay, so he has made it, and this is exactly what it looks like. This is what's going to be in the exhibit hall. Okay. So, sculptor hands this to you, and I'm just going to do this. All right. So, there's the sculpture. How does it look? Can't see it. Not everybody can see it. So, how would you define this problem? Let's it's pretty clear we've got a problem here. So what is the problem? The sculpture is too small. Now, unfortunately, this is what we have to do. The sculptor already made that sculpture. Okay, he's handed to you. You have to work with it, whether it's small or big. That's what you're dealing with. So, aside from the sculpture itself, what is the problem? The visibility. Okay. Tough to see. All right. Any other problems? Okay. Well, so that seems to be the main problem. We can't see the bear. It doesn't really do us much good if none of us can see it. And so that's where you come in, your engineering team. You're going to be working in your groups to solve this problem of how can guests see the sculpture, all right? And the idea you're going to have with your team is to make a tower, okay? You're going to make a tower, and you're going to put the sculpture on that tower, okay? So that's what you're going to do. What do you need to know in order to do that? What do you need to know to solve that problem? Yeah. Okay, so how high are the ceilings? Okay. Is there anything else? Sure. What materials are available to build the tower? Add question marks here. All right, how are the ceilings? What materials? What else do we need to know? Yeah. How much room do you have? Okay, how much room do you have? Square footage. All right. Anything else? Yeah. Budget. Very important question. All right. Yeah.
Location.
Location. What is the location? How much does the sculpture weigh? How much does the sculpture weigh? Okay. So, what is like the viewing distance? The viewing distance. All right. Is there anything else? Yeah. Okay. What is the base of the sculpture? Anything else you can think of? Okay. Are your supplies limited? Are your supplies limited? Okay, so we've got a pretty long list. So what we're going to do is we're just going to go through and try to answer them. And I may provide some more information to you after we've addressed these questions. So how high are the ceilings in the exhibit hall? Okay, so the ceiling height is up there. Okay, that's the ceiling height, just the height of this room. What materials are available to build the tower? So the materials you'll have available are these. you all are going to get index cards to build your tower, okay? You're going to get 100 index cards to build your tower. You will also be getting a foot length of cellophane tape, okay? 1 foot of cellophane tape, index cards, and you will also have tools to help you make your tower, okay? The tools you will use are scissors and rulers to help you measure the height of your tower. The scissors and the rulers are tools and tools only. They will not be used in the tower itself. It will just be used to help you build the tower, okay? So those are the materials. Let's go through. How much room do you have? You have as much room as there is on your table. That's how much room you have to build. Your budget. We won't be concerned about the budget. We've already allocated the funds for your materials. Okay, so all you have to be concerned about is the materials that you'll be using. So the index cards and the tape. The location. The location of your tower is right on your table. That's the location. How much does the sculpture weigh? Good question. What we're going to do to kind of figure out the weight of this sculpture is to feel it. So I'm not going to allow you to keep it the entire time that we build, but I will come around when we start our time, and I'll let you just kind of feel it and get a sense of how heavy it is. And I will leave it to you to figure out a substitute for the sculpture itself. We want to protect our sculpture. We don't want it to break. So we're only going to actually test it at the very, very end. So all you can do is feel it. What is the viewing distance? The viewing distance will be from where you're sitting to where you build the tower. That is the viewing distance. All right, so the base of the sculpture, you can make the base of your sculpture as wide as you'd like, as long as it fits on the table. Are your supplies limited? Yes, they are limited. You only get those 100 index cards. You only get that foot length of tape. So you'll have to use those the best you can. Now, here are some other parameters that didn't come up, and I'll just tell you about those. Your towers have to be 2 feet tall. Okay, so we've got our rulers here. So 2 feet, 2 of these rulers is how high you need to make your tower in order for it to be properly visible to your guests. Okay. You are also limited by how much time you have. You will only have 18 minutes to think of your design and to build it out. Okay. 18 minutes. Let's see if anything else you need to know. Yes, the person you are sitting next to is going to be on your engineering team. Okay, so you'll be working together there. And also, when you're finished building, okay, let's talk about how will we know if we are successful? How will we know if we've done our jobs as engineers? If it holds the bear. That is a good criterion. If it doesn't hold the bear, then we have not succeeded. All right. Yeah. Yes, so we should meet the height specification set out by the museum. So it needs to be that 2 feet tall. Okay. So we'll know we'll be successful then. If it holds the bear and if it's 2 feet tall. How could we test those things to make sure we meet the criteria? How could we test that? What could we do to make to find out whether it holds the bear or not? We put the bear on. Yeah. So we're going to put the bear on, and we also need to think about another parameter. How long can it hold the bear? And let's settle on that as a group. How long would you like your bear to stay on there? What do you think would be a good amount of time for it to be held there? 3 seconds. Okay. So, anyone have other, or do you want to, or do you like 3 seconds? Is that okay? 3 seconds is okay? Okay. So it'll be 3 seconds. All right. If it holds it for 3 seconds, then we'll say that is a successful design. All right. At the very end, okay, we will go around and test your towers. All right. And I will let you place the bear, so you don't have to worry about how it's placed because you'll be placing it yourself. All right. So, are there any other questions that you have before I start passing out materials? Yeah. Okay, so you're thinking very optimistically. All right, so they all hold the bear. How do we know? How do we distinguish between the different, I suppose, proposals? So that's something to think about. What do you think? Well, if we have multiple designs that look good, how do we decide which looks best? Raise the time. Okay, so if we have a successful design, we can possibly extend it past that 3 seconds. Well, that's a very important consideration. So it's how much did you use, right? We don't want to spend more than we need to, so it's efficiently holding up everything. Sure, so the aesthetics of the design might be a factor, okay? And we can just kind of judge the aesthetics as a group if it comes to that. All right, so looks like we have everything we need to know now. So what I'm going to do is I'm going to come around and give you a package of 100 index cards, and I will be cutting out a foot length of tape for each group. And I will put some time up on the board so you can keep track of how long it's going. And so as soon as you get those things, you can start. But while I'm passing out those materials, feel free to start talking about what you envision it to look like. Yeah. Cut tape. Oh yeah, yeah. Okay, I'll cut the tape. Yeah.
Right, but small pieces. And then you tape it like right here, like right in the middle of where it meets. Oh yeah, yeah. Yeah, let's do that.
Okay, this one got a little screwy, but I think that should be okay.
Alright, we'll ask for more.
Yes, so I'll add an additional centimeter or so if you need it.
So then do you want to put a platform? That's what I'm worried about. Yeah.
Okay, here's your tape. Oh, wow, that was fast. Okay, cool. Just good idea. All right, cool. Thanks. All right, cool. Would you like to feel the bear?
Yes.
Get a sense for its weight?
Okay, not as bad as
All right.
There you go.
There. All right. Good. So you're set. Would you like to feel the bear? Get a sense for its weight. right. Cool. You all set then? Just want to feel the bear. Sense for its weight.
Feels like.
They still don't
Yeah.
have power over. Can it be over 2 feet tall? That was my question.
Sure. Yeah. Yeah. It can be over 2 feet.
Couldn't be.
Minimum of 2 feet.
Okay.
Yeah. Would you like to feel the bear? Get a sense for its weight. Too heavy. Yes. Would you like to feel the bear? So, we're good? Yeah, all right. Would you like to feel the bear? All right. Got a good sense of it. Would you like to feel the bear? Get a sense for its weight?
Oh, I can't test it.
Oh, not yet. You'll have to find a substitute. Oh, good idea. Well, we'll talk about that. So what are you thinking for your design?
Well, I know we need triangles.
Okay, triangles are a factor.
The best way to. We want them to be together without having to use tape, so we tried cutting
Oh.
it first.
Okay, so
To
thinking
like give it space to go in.
Nice.
And then we would only have to use tape to connect the bottom part.
Oh, I see. That's a cool idea. All right, we'll see how that works. Good luck. All right, how's it coming over here? Coming? All right. Cool looking design. So what's your idea?
And then, yeah, because you might fit on there because leg
So, cute. Oh, well, we'll be testing the bear at the very end. But yes, you were placing the bear. So.
So, you know, these are great.
What's your idea for your tower?
So we're kind of doubling up to make this a little more sturdy and doing a starburst little.
Oh, neat. Starburst, very cool. Looks like a very sturdy layer. Nice.
always way heavier than the bear, right? So. I do. Oh, yeah, I'm sure you do.
All right, so how's it coming? Looks good.
We're going for the least, and also the least amount of material.
The least amount of materials. Okay. All right, cool. It's pretty